What about the geometric? What's the deal with it? Good. It's got a ratio. It's multiplying and dividing. Good deal, good deal. All right. So we know from probably about the 5th grade that mean is just an average. So if we're looking at arithmetic or geometric mean, we're just finding the average of a set of numbers. Okay? Your arithmetic mean, we're going to call it AM. Your arithmetic mean is just what you would think it is. Okay? You're going to add up your first term plus your second term plus your third term plus your fourth term to however many you have to the last term. And then you'll divide it by how many terms you have. Okay, that's nothing new. Just got some different symbols that have to do with sequences and series. But to get the arithmetic mean, you just add them all up and divide by how many there are. So, if I gave you 5, 25, 125, oh, we can't do this yet, 625. Okay, let me think of a question that I can ask because we can't do that yet. Is that sequence that I just gave you there, is that arithmetic or geometric? Okay, if it's geometric, that means it's got to have a common ratio. What's it being multiplied by every time?
5.
So it would have a ratio of 5. Okay, so we'll use that one in a second when we get the formula for a geometric mean because it's different. You got to do something a little bit different on geometric mean. So let me do better this time and pick one that is arithmetic. That was stupid of me. How about 11, 22, 33, 44, and 55?
So don't do that first one.
We answer 2 questions with it. It's geometric and it's R is 5. Alright, what about this one? Is this one arithmetic or geometric? Okay, if it is arithmetic, that means it has a D. It's being added or subtracted by the same thing every time. What's its D?
11.
Okay, from 11 plus 11, 22 plus 11, 33 plus 11, so that one is arithmetic. So we would find now the mean of that, just like we learned to find the averages when we were in elementary school. We're going to add all those up and then divide by how many there are. So you're looking at 11 plus 22 plus 33 plus 44 plus 55 divided by 1, 2, 3, 4, 5. Make sure on your calculator, since I already hear the button pushing, after you hit plus 55, you've got to hit enter before you divide by 5 or it'll do it in the wrong order. Okay, what'd you get on that? 33. So our arithmetic, you got 33?
Yeah.
11, 20, did I write them down wrong? 11, 22, 33, 44, 55. Okay. That's not what the book has, but that looks right. Huh. Let's see what they did. 11 plus 22 plus 33 plus 44 plus 55 was 165?
Mm-hmm.
Okay. We should have marked that out.
What is that?
They said it equals 231.
What?
Alright, now, make sure, we think for the geometric mean that it would have the same formula, but it's a little bit different. So make sure you've got that one there, your normal average, that's labeled as arithmetic mean. Okay, your geometric mean, GM, to find it, you're going to take the nth root, where n is how many of the terms you had, and underneath that radical, you're going to multiply all your terms. To your last one. A1 times A2 times A3 times times AN.
Is that F is equal to?
GM, geometric mean. Kind of does look like it. Alright, so we'll go back and use that sequence that we've already identified as geometric that I wrote a second ago. We've already talked about this as geometric because it would have a ratio of 5. So how many terms did I give you there? 1, 2, 3, 4. So that's what root you're going to take. Okay, however many terms you have, that's the root. So we're going to do the fourth root of 5 times 25 times 125 times 625. If I were you, the order I would do this in is I would multiply everything underneath the radical first, and then I would go back and do the fourth root of it. And you can round to, let's round to the hundreds. You remember how to do fourth root after you get them all multiplied? Gotta hit 4 and then go to math and pick the one with the X in it.
Right?
Yes, sir.
55,
90, be good. Good deal.
I have a question. In your, the example you said, you said A1, A2, A3, and AP, is that, why did you just roll?
The last term.
Where did you get the 4?
There were 4 numbers, so however many numbers is what we'll go to. Now, the question Macy just asked me, she didn't ask it for this reason, but this brings about a point for something we talked about on Wednesday. Could I find the geometric or the arithmetic mean of an infinite series? No. It's got to be finite, doesn't it? It has to end. You got to have a last term. Because you can't add up numbers and tell me one answer when the numbers keep going. So, something to think about on that. Alright. What are you okay on means? You've done mean, mean, and mode, you've done averages, so that geometric formula is different though. I would be interested to know how they came up with that. I don't understand where it came from, but nobody's ever taught it to me, so I don't know. Alright, series. It's the next thing that we got on our list over there. What we got to know is, and this is a weird definition for me, because if you say series, I just think about in a row, things like a series of TV shows. You watch episode 1, episode 2, or whatever. A series, it just keeps one in a row. But with this data, this stuff that we're doing now, a series is actually means the sum of a sequence. So it's just, you're adding them all up. It's not the average, it's not what we just did, it's not the mean, it's just the sum of them. Okay? There is an arithmetic series and a geometric series. Today we're only doing arithmetic. So the formula for an arithmetic series your sum is equal to number of terms times your first term plus your last term divided by 2. Now, yes, you could just add them all up. In that, like if I gave you, let's see, 1 plus 2 is 3 plus 2. If I gave you that and asked you for the series, I could just do 1 plus 3 is 4 plus 5 is 9 plus 7 is 16. I could do that real fast. But if I gave you 100 numbers, that's when it would be easier to plug into this formula. So it's just all up to you on what they did. All right, let's just use that little baby one there that I gave you, 1, 3, 5, 7, since we know what the answer is to check out this formula. Yes, over 2, all divided by 2, yes. So the sum of this series, and we know it's arithmetic because that adds 2, right? That adds 2, so I picked a good one that time, not like last time. The number of them, which is 4, times the first term, which is 1, plus the last term, which is 7, all divided by 2. 1 plus 7 in the parentheses is 8. 8 times 4 is 32. So you got 32 divided by 2, which is what I said, doing it in my head real quick.
How do we get 4 for n? I wasn't here.
How many terms there are? N's always the number of terms. It is, but like I told you on Wednesday, it's just, there's going to end up being a lot of formulas. Like, this is just our second day on this stuff, and we've already got a third formula. No, we've actually now got 5, right? We had 2 Wednesday, now that's our third one today. So you got to keep them good and labeled so you know when you're using which one. All right, let me give you another one of those. A base N always means the last term. Yeah. All right, let's see if we can find. It says compute the sum of this arithmetic sequence. I've got 4, 9, 13, 17, 21, and 25. See if you can do that using the formula. Try that and see what you get. I've got mine set up, just plugged in the formula. So I had 6 terms, so that went in the end spot. My first term was 4, my last term was 25, and then that will be divided by 2. So 29 times 6, that becomes an iffy one for me on would I use the formula or would I just add them all up, because I don't know 29 times 6. So if I got to get my write out or get my calculator to do that, then I would probably just add them up. That's where I am on this formula stuff. But still, they could give you like from, and we'll do this one next, from 1 to 100. You ever thought about what the sum from 1 to 100 would be? We'll look at that one, do that one, be our last one to look at. But this one,
it goes 4 plus 5, and it goes 9 plus 4.
this is the same stupid one we had the other day, isn't it?
Yeah, it's not like this one. I got a different answer when I just added them up. Me too.
Yeah, well that's because was it this class that I used that? And we,
No, I don't remember that. No, but I
Yeah.
goes plus 5.
I used this same string. I figured this stupid workbook has more mistakes than any of them I've ever used. We used this one on Wednesday, and somebody caught it in a different class. From 4 to 9, it's 5, but then the rest of them is 4. So to make this one work, we need to leave the 4 off. So go back and turn your 4 into a 9.
And then just make that 5 instead of 6.
Yeah, it'll be 5 instead of 6. I forgot that we found that out on Wednesday, or I would have picked a different one. So that's good, Kylie, on y'all noticing that.
Hey, you can still use your calculator.
Yeah. Write that down again.
I wasn't sure if I just like made a mistake and I
No.
popped in my calculator. So
I guess on Wednesday I must have did a different problem with y'all than I did with them, because I used that string of numbers and they're like, it's neither one. What?
Remember when you
Yeah, we'll go just a little bit. All right, what everybody get now that it works?
85.
85. All right, want to do that last one I was talking about with you? I'm going to show you how you would write something like this. I don't want to have to write out.
Is this another arithmetic?
Yes. Okay, so that would include all the numbers from 1 to 100.
would be 100, your n would be.
Okay, so that's the first dilemma, is what is my n? How many numbers are there 1 to 100? What's my first term?
1, 1.
What's my last term?
Seriously, just stop 1 plus 100%.
Also known as 5,000. Thank you. I went on a tangent about that on Wednesday.
Who was it that one of us said something?
You did.
Me.
That
No, it
was
was
me.
Caitlin.
So if you added up 1 plus 2 plus 3 plus 4 plus 5 plus 6 all the way to 100 would be 5,050. So that's definitely, for sure, I would do the formula on that one.
I wonder like how people come up with these formulas.
I don't know, that's interesting to me.
And why does
It's
it matter?
interesting to me that makes me ask, but then I don't want to figure it out. I'm like, nah, you're good.
It's cool though, like
Yeah.
how they.
Yeah. How many problems do they got to do before they decide
I know,
it's
like-
true?
I would never like.
Because sometimes
who would
stuff
do that
works
for
one
a while?
time and then not anymore.
But why do we need it?
Is that it?
So do you want to add up all 100 of them?
No.
What if your grandma gives you $1 today, $2 tomorrow, $3 the next day, $4 the next day? How much money will you have at the end of 100 days? I might want to
Just
know
put it
that.
in your calculator.
You're going to do that
You would
all
have
the
to
way
add
to
up 100
1
numbers.
plus 2 plus, you know. Put it, look it up on Google.
Yeah, well, somebody in the world had come up with this.
to tell Google. Somebody had to tell Google. All right, next after, we're not going to do it today. That's a short, easy schmeezy stuff for you today. Next is geometric series. There's a different formula for finding the sum of geometric. Okay, Monday you're going to have an assignment over some stuff. My mom's having surgery, so I'll be there Monday.
I thought better when I saw that thing yesterday.
I don't know why everybody didn't get 9 on
I
mine.
thought it was so easy, and then I
think
made
yours-
66 on it.
How many did you get? 7 out of? No, you must have got 6.
And I thought it was so easy too. I thought it was 78.
I made them 2 points.